Hello everyone, welcome back. In the last video, I proposed a question for you guys to solve, and now I'm going to review the answer. Okay everyone, here is the problem. A particle moving along a curve in the xy plane is described by the position function cosine t sine t for t is between 0 and 2 pi. Find the function that describes the average displacement of this particle as it completes one revolution. Okay, the question is asking us to find the function that describes the average displacement of this particle as it completes one revolution. Let's first analyze this diagram. Okay, let's draw this out. This is our xy plane. This is our circle, which is not very good, sorry. And this is the origin, 0, 0. This is the starting point, it's 1, 0. This is the half point, negative 1, 0. Okay, it is quite obvious that when the particle complete one revolution, the average displacement will be in the center of this graph, which is the origin. The question is how to find a function that describes the change in displacement over time. Well, we know that the function must stay in the upper part of this xy plane because when the particle starts moving beyond the point negative 1, 0, the displacement in the negative half of the circle will cancel out with the positive half of the circle. So the function might look something like this. I'll use another color. It looks something like this. This is the end point. When the particle completes one revolution, it will come back to the origin. Alright, so the next thing we have to do is to find the average displacement of this particle. We know that the average velocity is equal to the change in displacement over change in time. Similarly, the average displacement must equal to change in something over change in time. And this something must be the integral of displacement, or the area under the displacement curve. So we can write our formula. Average displacement is equal to the integral from 0 to t, the function of t, x of t, dt over change in t, change in time. Okay, now let's plug our function in. This is equal to integral of from 0 to t. Our function is cosine t, sine t, dt over t minus 0. Okay, now we have to, in order to solve this, we need to take the antiderivative of our function, which is equal to sine t, evaluate from 0 to t, negative cosine t, evaluate from 0 to t, over t. Okay. And this one is equal to, next thing we need to do is to plug our limit of integration in. This one will be sine t minus sine 0, which is 0. I'm not going to write it. And negative cosine t minus, because we know that negative cosine 0 is negative 1. So negative cosine t minus minus 1 is plus 1. So okay, this will be our function. This will be our answer. And we can rewrite this one as sine t over t, comma, negative cosine t plus 1. Sorry for the short interruption. Here we got our function sine t over t, comma, negative cosine t plus 1 over t. Here is our answer to the question. A function that can model the average displacement of the particle as it completes one revolution. Now let's put this function into a graphing calculator. Now we are going to put our function into a graphing calculator to see if it is right. This is the origin function. It is a circle. Now we enter our new function, sine t over t, comma, negative cosine t plus 1 over t from 0 to 2 pi. Okay. We can see that the function matches with our prediction. It stayed in the upper part of the xy plane and it ends up in the origin when t is equal to 2 pi. So in this case, we can conclude that our function is the right answer. Right. In next video, I'll examine the property of this function with you guys. Hope to see you there. Thanks for watching. Bye.